Okay, now you're going to learn a new type of factoring, but it's easy. It's much easier and much less work than the T-chart and all that stuff, okay? On the board, on the left, the right, and that's been up there pretty much all year, you see a list of perfect squares. So 4 equals 2 times 2, and by the way, 1's up at the top. 1 equals 1 times 1. 1's a perfect square. 4 is equal to 2 times 2, so 4 is a perfect square. 9 is written as 3 times 3. 9's a perfect square. And then it goes on down the line. I went all the way down to 169. You'll never have to go further down than that. Okay, here's what I want you to do, and this seems kind of silly, and you're not really going to need a calculator because you have on the board what you need, okay, and that always stays up there. I pretty much have that on the board throughout the whole year because it's used all the time in Algebra 2 and so forth. Now, identify the expressions that represent a difference of perfect squares. So the word difference means you have to have a minus sign. So that one has a minus sign. If it has a plus sign, you just write no and don't worry about it, okay? So we have a minus sign. That's the first thing you have to have. Now, is 9 one of the numbers on the board? Yeah, because that's 3 times 3, okay? And you look on the bottom, x to the second is also on the board at the very bottom because that's x times x, okay? So it's a difference. That's a perfect square because I can write it as something times itself, and that's a perfect square because I write that as something times itself. So that's a yes. Okay, now the next one, I don't worry about what's there. If I see a plus sign, it's a no. Okay, it has to be a minus. Okay. If I see a plus sign, it's a no. Just don't even overthink it. This has a minus, but 14 is not on the board. That's because you cannot write 14 as a clear whole number times itself. So that's no, okay? I have a minus here. Now is 25 on the board? Yeah, it is. It's 5 times 5. Now is 16, now you see 16x squared. Now is 16 on the board? Yeah, it's 4 times 4. Now, x to the second's also on the board on the bottom because that's x times x. So I write this as 4 times 4, and then I hook an x onto each because I know that that's 16x to the second, okay? So that is a yes. I was able to write that as a perfect squares. Okay, right here. Minus is there. Is 81 on the board? It is. It's 9 times 9. Is 4 on the board? Yeah, 2 times 2. Is x to the second? Yeah, it's x times x. So that's written as 2 times 2, and then I hook an x onto those because x times x is x squared. 2x times 2x is 4x to the second. So that's a yes. Okay, next one. Your minus is there. Now 49's on the board. That's 7 times 7. But the 3 is not on the board, okay? I cannot write 3 as something times itself, so that's a no, okay? Everything has to be able to be written as something times itself, okay? Minus, so 64 is up there. It's 8 times 8. 49's up there, 7 times 7, and then the x to the second's x times x, so 7x times 7x, so that's a yeah, buddy, okay? Pretty hard, okay? Okay, first I have minus, so 144 is up on the board because that's 12 times 12, and x to the second's on the board because that's x times x, so yeah, buddy. Plus right away means no, okay? If you see a plus, you shouldn't even worry about anything else. I've got a minus, 1's on the board up top. Now you're like, why is it crossed out? Well, not in this class, don't worry about it, okay? 16 is 4 times 4, and that's x times x, so that's 4x times 4x. Minus is there, so 100 is 10 times 10, and 7 is on the is not on the board, so that's a no. Okay. If it's plus, I don't care what else is there, it's a no. There's a minus, so that's going to be 9 times 9. and the 4's up on the board because that's 2 times 2, and x to the second is x times x, so that's 2x times 2x. Okay, so that's yes. Okay, you got a plus, that's right away a no. A plus right away is a no. Okay, I want to see if there's any on the thing that are weird. No, I think you're pretty well set. Pause the video, do those 8, and then there's another thing we're going to do. Okay, now I'm going to do what I did. Now, anytime we're learning a new technique of factoring, I like to put some multiplication problems first, okay? And that's what you're going to be doing on 1, 2, 3, and 4, okay? So first we need to multiply, then we need to come up with our like terms. So I got 1x, 1x. So first I take 1x times 1x, okay? And then I take 1x times negative 5. That's dead. Then I take 5 times 1x. 5 times negative 5. Okay, so 1 times 1 is 1, and then these are to the first power, so we need to add those. So x to the second. 1 times negative 5 is negative 5. Heck, if you want to put a 1 there, be my guest. That's the only one you have, so it's x to the first. 5 times 1 is 5. Heck, put a 1 there. It's just going to be x to the first. That means the same thing as just x. That's why I don't usually put it on there. Negative 25. Okay, so that's done. Okay, so I put blank x second plus blank x plus blank. X is second, so I have 1. Now, x means x to the first. Well, I seem to have 2 of those. But when I add those, that's 0. So we get rid of this, okay? And then I put the negative 25 here. Now, remember, this right here means 1x to the second, and plus negative is the same as minus. You don't need to write that. I'm just making a point here, okay? This is good enough. So you notice how the middle x dropped out, okay? And the reason why it dropped out, because I had the same thing in each parentheses, except one was a plus, one was a minus. Okay? All right, next one. So I take 6x times 6x. Oh, by the way, I like to order this when I'm doing this. And then 6x times negative 5. So that's done. Then I take 5 times 6x and 5 times negative 5. So again, heck, put 1s. 36x, 1 plus 1's 2. Negative 30, put a 1. It's just to the first, so because that's the only one we have. 30 first, and then negative 25. Okay, now with that done, that's done. Blank x second plus blank x plus blank. Okay, so x second, you got 36. X is the same as x to the first, so we add those, and oh, what do you know? That equals 0. Okay, so get rid of that. And I get negative 25. So that's good enough. Now I'm going to personally write here 36x squared minus 25. The middle x dropped out. That's because we had a plus and a minus of the same thing. Okay, do a couple more here. This just gets kind of, it's easy, but so 3x times 3x. 3x times negative 7. 7 times 3x. 7 times negative 7. So 3 times 3 is 9. 1 plus 1 is 2. Negative 21, and then that's to the first. You just put it to the first because it's the only one we have. That's 21, x first, and that's negative 49. So, and then 9, those can cancel out, and then we got negative 49, okay? Okay, again, 9x second minus 49. I'm not going to waste your time doing that one. Just go do, you don't need to do 4 of them. Just do a couple. Let's just do 1 and 2, okay, because we got bigger fish to fry here. Okay, you want to put 1s in front of those. Okay, now here's what you're going to be doing here. You're going to factor the expression, and what you're going to use, it's what's called, you're going to hear me say it a lot, it's called DOPS, okay? It stands for something, okay? Difference. I'm going to write, it's on the board too, of perfect squares. So if I ask you what DOPS, I'm going to use that term a lot, and I'm going to occasionally have you guys remind me what it means. Difference of perfect squares. So from now on, when I see two terms, you don't have to worry about the GCF today, okay? You will continue worrying about it tomorrow, okay? But for today, I don't need you wasting time with the GCF. All these are differences of perfect squares. You need to factor them. Okay, you're trying to find what times what would equal this. Well, you can see that the middle x term has been dropped out. It goes from x squared to a number without an x. Okay, so first we make sure we have a minus, and we do. 49's on the board. That's 7 times 7, and x to the second's x times x. So it's a yes. So I make two parentheses. And it needs to be a plus and a minus of the exact same thing. So I put x from here, and then I put 7 and 7, okay? And I know if I multiply that out, the middle two are going to cancel, and that's going to be what I get. Okay, next one. Again, there's a minus. 49's on the board. That's 7 times 7. 36 is on the board. That's 6 times 6 and x times x. So 6x times 6x. It's a DOPS, difference of perfect squares. So 6x, 6x, and then 7 and 7. Okay, again, that's why I write that, so I know exactly what I'm going to put. Okay. Okay, next up. See if it's a DOPS first. DOPS meaning difference of perfect squares. So DOPS, the D means difference. Minus got to be there. Okay. Is it a perfect square? Well, 4 is 2 times 2, and 25 is 5 times 5. X to the second's x times x. So 5x times 5x. So as soon as I know it's a DOPS, it's yes. So I make two parentheses with a plus, a minus, and then I put the exact same thing. So 5x, 5x, and then 2 and 2. Okay, next up. There it is. 9's 3 times 3, and that's 2 times 2, and that's x times x. Again, this has to be a minus, because if it's plus, you can't do anything with it, but all these are minuses. On the where you put that last part of the sign where you put yes, no. Well, so plus, minus. Okay, so 2x, 2x, and then 3 and 3. Okay, more fun on the next one. Easy stuff, though. 4 times 4, and that's 5 times 5, but it'd be 5x times 5x because we have a second power. So 5x, 5x, and 4 and 4. Okay, I have a minus, and then 10 times 10, and then 3 times 3. With the second power, it's x times x, okay? Okay, so I have 3x, 3x, and then 10 and 10. Again, if you multiplied that out, you would end up back here, okay? Okay, I've got minus, and that's 2 times 2. 81's on the board. That's 9 times 9, and x times x, okay? So it's a plus and a minus, so 9x, 9x, and then 2 and 2, okay? And then I have minus 81's 9 times 9. X to the second is x times x, okay? And x, 9, 9. There we go. All right, guys, so I'd say today you can do the last 4. Those don't take any time.